All right, today's lesson is on factorials and permutations. So a permutation is basically a way to arrange a group of objects in which the order matters. So an example of when the order would matter would be like, let's say, a locker combination. When you go to put in a locker combination, you have to make sure you put everything in the right order, otherwise it won't open your locker. So as you read through these, all of these on this first part, for sure will have order that matters. And then tomorrow's lesson will have it where order doesn't matter. You can kind of compare the difference. So basically we're choosing a president, a vice president, and a secretary. So order matters because we don't want the secretary to be the president or vice versa. And we're choosing 7 members. So there are 3 positions. So one way to kind of look at these is to say, okay, I have 3 people that I'm trying to fill for: a president, a vice president. So here's president, vice president, here's secretary. And there are 7 members. So that means that for the first position, I have 7 people to choose from. Now, one person became president. So now when I go to choose for vice president, there are 6 people to choose from. And now somebody's vice president, and now there are 5 people to choose from. So 7 times 6 times 5, which will give you 210. Next one, we have 10 runners. We want first place, second place, and third place. So again, this is the piece that's telling us that order matters, because somebody who gets third place would love to be counted as first place, but the person who got first place, I'm sure, doesn't want to get third place. And it says there are 10 runners. So there's a first place, second place, third place. So those are our positions. So first, second, and third. And there are 10 people to choose from. So 10 people, then 9, then 8. So 720 different ways where the order matters. Next one, 9 players on a baseball team. The coach is going to choose the batting order for all 9. So order definitely matters here. So if we have 9 players, 1, 2, 3, 4, 5, 6, 7, 8, 9, and basically you're just doing the first person that's going to bat, the second person, third, all the way until you get to the 9th batter. And so when they go to pick the first order, there are 9 people to choose from. Then that person stayed for the first spot, so now there's 8, and then 7, 6, all the way down to 1. So 9 times 8 times 7, all the way down, because everybody is important in their position. This is called, different color, this is called a factorial. So 9, and it looks like an exclamation mark, is called a factorial. And it basically means that you're going to do 9 times 8 times 7 times 6 times 5 all the way down. Okay, so we're going to practice that real quick. There is this on your calculator. Usually you have to go to like a second key. So 5 factorial basically means you're going to do 5 times 4 times 3 times 2 times 1. So again, if you don't have the button, it's fine. Multiply all that together, you get 120. For number B, if you have 8 factorial over 3 factorial, I'm going to write out what that looks like, but you can definitely do some cross canceling. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. You're going to notice the last 3 terms are the same. So the 1s obviously can go, 2s can go, and the 3s can go. And then basically you're just doing 8 times 7 times 6 times 5 times 4, which will give you 6,720. So the next part we have is actually figuring out how to use a formula. So a permutation, this is your formula for permutations. Okay, the n here refers to the total number of objects. So So this n is the total number of objects. And the r is the number of places we're trying to put them. Put them or order them. The wording is a little bit weird. So if we just step back for a second and we go back up to the beginning examples, because they can be done with a permutation formula as well. So for instance, for this one, we had a total. This would be our total number, which would be n. And we're trying to fill 1, 2, 3 positions. So r would be 3. So you could use this as 7p3. If you did this computation, there's a button on the graphing calculators that has this. This would give you the same thing as this, 210. Same thing here. If you have 10 runners and you have 3 positions, it's 10p3. And that would give you the same answer like the other ones. So let me show you kind of how to work the formula. So basically, you're going to notice you're going to take the first number with the factorial over the n minus r to the factorial. So for instance, for this first example, this is your n. And this is your r. So you're going to have 7 factorial over 7 minus 4 factorial. So that ends up being 7 factorial over 3 factorial. And then you can cancel out. So let me write what that would look like. 7 times 6 times 4 times 3 factorial is how I'm going to write it, because I have a 3 factorial on the bottom. It's really 3 times 2 times 1. But if you write it like this, then you can kind of see the cross canceling a little bit easier. So I have 2 3 factorials. I can just cross them off. And then basically, oh, I missed a 5. Hold up. There should be a times 5 here. Okay, so 7 times 6 times 5 times 4. Those cancel. If I multiply that out, I get 840. And then let's try another one just to make sure we know how to use this. So 10 here would be our n. 6 would be our r. So it'd be 10 factorial over 10 minus 6 factorial. So 10 factorial over 4 factorial. You should be able to see that the 4 factorial will cancel up here. So let me write it again one more time long way. So 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial over the 4 factorial. The 2 4 factorials will cancel out. And then you have to multiply this still together. So you get 151,200. And then our last example, 6p6 would be a 6 factorial over 6 minus 6 factorial, which would be 6 factorial over 0 factorial. Now in math, sometimes we have some secrets. This is one of them. 0 factorial is equal to 1. Okay, so it's not 0 because we don't want to get an undefined function, but 0 factorial is equal to 1. So then this would be basically a 6 factorial over 1, and 6 factorial is just 720. Sorry, I switched colors. And that would be the answer for that. So then when we come down here for number 6, now you have 2 ways. You can either list out the different possibilities by hand, or you can use the P formula. Either way, you get the same answer. So here you're trying to figure out how many ways to line up 7 floats. So that could either be a 7 factorial, or it can be a 7p7. Because you're trying to do 7, then 6, then 5, all the way, just like we did the batting problem. It's very similar to this problem here. So you can do it either way. When you do the 7p7, the math would be 7 factorial over 7 minus 7 factorial. So 7 factorial over 0 factorial, which we just said is 1. So basically 7 factorial, so 5,040.